about the use of mirrors formula and magnification formula for concave mirror. Now we'll similarly focus on convex mirror. I have brought again the ray diagrams. I have pre-drawn so that we can save time. I can focus more on explanation. Drawing and explanation parallelly will take more time. That's why I drawn. Then I'm looking at the diagram. I'm explaining. Okay, there's a convex mirror. I'm picking up like a mirror of focal length plus 10 centimeter. Real object beyond pole. Okay, first thing. Okay, let's begin here. So what is the object? Will be minus 30 centimeters, or I'll start with 15. Height of the object 2 centimeters. There's a real object I kept here. There's a real object is what I kept here. Agreed. Then what is the direction of incident ray? The direction of incident ray should be towards positive. Let me indicate here. These are the direction of incident rays. Okay, let's go to our formula. So the ray after the array incident ray parallel to principal axis after reflection should diverge from focus. Fine. Sir, where is the principal axis? This is the principal axis. Or some books, they call it as optic axis, either one, or only axis. Then another ray incident at pole. Another ray incident at pole after reflection. Okay, this will be reflected. Look at these two reflected rays. They're diverging from a point. They're diverging from a point. Okay, I'll reproduce back where these two like a reflected rays diverge, where they intersect. No, that will be the position of image. So here for virtual object, HO, this will be I. So virtual image, there's a real object. Okay, let's use the formula, mirror formula, 1 by V. What is the object distance? Minus 15 plus 10. Why it's a sign C or why the negative, why minus 15, why this be plus 10? All the distance I should measure from the pole. The incident rays are towards right. So what is the object distance? This will be minus 15. And look at the focus. Focus on the right side of the pole. So I'll measure from the pole the focal length, no? And I'm measuring in the direction of incident ray. So therefore, this will be positive. Very important. First time, no? Make observation. Object is on left side of the pole. Incident rays are towards right. So I'll measure the object distance is PO. How you measure? Opposite to incident ray. So therefore, negative. What about the focus? Focus is on the right side of the pole. We measure PF in the direction of incident ray. So therefore, this is positive. Okay, let's solve this. 1 by V, 1 by 15 plus 1 by 10. 150 by 25 will be plus 6. Magnification plus 6. U is how much? Minus 15. So this everything will become 6 by 15. I think will be less than 1. So will be diminished the image. Then height of the image. See, it will be less than 1 cent. It will be diminished. So therefore, what is the conclusion? Real object beyond the pole. So whatever the image will be between pole and focus. Between pole and focus. Virtual, erect, and diminished. Okay, fine. So this is the first condition. Okay, now you do one thing. Change this minus 30, minus 60, like this, keep on increase. You start moving, make it move away, this object away from the pole. What should happen? You can see that as this distance increases, and this will increase. Definitely V will further decrease. As U increases, V will decrease. There's a formula, mathematically try to analyze. So finally, when U is infinity, where the V will be? V will be at focus. So therefore now, so as you increase the object distance, so what will happen to V? V will increase here. V will increase. Look at the mathematics here. As you increase U, V should increase. So finally, object at infinity, image will be at focus. So if you move object from pole to minus infinity, image will move from pole to focus. Fine. Put U equal to infinity. What is V? V equal to F. So image will be here. If object at infinity here, image will be at focus. Already we have discussed, no, some. I'll take you back. Where is the object? Object at infinity, no? What about image? Image will be at focus. Are you seeing now? These rays are coming parallel to principal axis. Means object is at infinity. The image will be at focus. Okay, I am here. Yeah. Let's take the next condition. Virtual object between focus and center of curvature. This is a real object. So real object, it will just form virtual image. There's only condition available. Next condition, I'll bring it. Virtual object kept between focus and the center of curvature. So again, the focal length of the lens is how much under consideration? F equal to plus 10 centimeter. Now also the same lens, same mirror. Object distance is how much equal to plus 15. I'll take it. And towards right, the distances measured towards right should be positive. It's a virtual object. We have to check it, whatever the image position. Okay, I do have space here. Let's use the formula. U is equal to how much? Plus 15. Then magnification formula, M is equal to -2. Then height of the image. Height of the object we have. Let me take this height of the object. So this will be +2. So -4 centimeter. I do have all the from the mirror form, magnification form. I'm able to predict that the image will be inverted, magnified. Okay, let's get into the ray diagram. There's a virtual object. So what is the virtual? The incident rays will converge at a point. You can see here. The incident rays are converging. These are incident rays. They'll converge at a point. So this is the position of virtual object. After reflection, this ray will go like this. And the green color ray after reflection will move. So these are the reflected rays. They are diverging from a point. So therefore, the image form must be virtual. I to categorize these rays. What are these? These are incident rays. What about these? reflected rays. So look at the reflected rays. They are diverging from a point. So therefore, the image form should be virtual. So what is the conclusion now? Virtual object between F and C. What about the image? Image will be between F and C, virtual, inverted, and magnified. Agreed? This one? Similarly, possible. So finally, in numericals, I'll be taking help of these formulas only. I'm just demonstrating how we can use the mirror formula. Okay, this is about the virtual object. Now, virtual object is brought between P and F. Again, the position of object, let it be 6 centimeter, height of the object 2 centimeter. Okay, let's see what conditions will arise here. So here, look at the diagram. There's a virtual object. These are the rays, incident. So look at the incident rays. These are incident rays. Huh? And what about this? These are reflected rays. So look at the incident rays. After reflection, they're converging to points. So if the image is formed by the converging reflected ray, that image should be real image. If the object is formed by converging incident ray, there should be virtual object. So the ray after reflection, so it wants to converge. The incident rays, if the mirror were not there, they would have converged here. So this should be the location of virtual object. After reflection, you can see this will go here. Similarly, this red color ray after reflection will meet here. So this should be the location of real object. Okay, let's use the mirror formula. 1 by V plus 6 plus 10. So this will be 6 minus 10 by 60. So V is equal to 60 by minus 4 minus 15 centimeter. What do you mean by minus 15? It should be on the left side of the pole. Towards right is positive, no? The convention, the incident rays. So if I say minus 15 means I should measure opposite to the, I should measure towards left, the position of image. PI should be towards left. Y plus 6, because the PO is measured in the direction of incident ray. Magnification. So this will be the height of the image. Look at this 15 by 3. Okay, so it'll get 5, no? Let me write it. So will it be magnified one? The final image will be. So therefore, whatever the conclusion image, will be either side of pole, real, magnified, and erect. So what is a convex mirror? So what it does, it's a it's a mirror, huh? Spherical mirror it is. Yeah. Convex mirror. What is possible? What is not possible? Convex mirror. What is possible? What is not possible? Conclusion. I will solve from here. For real object, image is virtual, erect, and diminished. Then for virtual object, what about image? Image is virtual, inverted, magnified, or diminished. It all depends upon position of object. Then for virtual object, one more condition is there. Image is real, erect, and magnified. What is not possible? For real object, convex mirror cannot form real image. I think that is what you are supposed to make notice here. Okay, this is about the mirror formula, magnification, and the image tracing. Everything I just included at one point. These are the very basics of spherical mirror. Okay, what all we do now here afterwards will be application part of this one. Okay, in the next class, what we'll start with some applications. We'll go for further applications of this one. Okay, I'll wind up the class. Okay, so similarly, we'll take this one. Third one, virtual object beyond C. Focal length of the mirror plus 10 centimeter. Object length, object distance, let it be plus 30. We'll see what conditions will arise here. Again, let me use the same mirrors formula. V is equal to 300 by 20 or plus 15 centimeter. Magnification so height of the image minus 1 centimeter. I got negative sign. So what is the conclusion I should make it? Whatever the image will be between C and F. Virtual, inverted, and diminished. So got the idea, this one. So where is the object? Object is kept somewhere beyond C. And the final image is formed between C and F. Okay, let's come for the ray diagram. Over the ray diagram. This is a virtual object. So the incident rays should converge. Okay, I took the here like this incident ray, this incident ray. So they are converging. No? You can see here. The point of convergence should be the location of extended virtual object here. Then after reflection, the rays will the reflected ray. So this will become reflected ray. It is diverging from this point. Similarly, after reflection, you can see this is diverging from this point. So this should be the location of virtual image. Fine. So this is about the ray diagram, and this is that axis. Principal axis, optic axis, or only axis. So when virtual object is beyond C, when virtual object is beyond C, where the image will be between F and C, will be virtual, inverted, and diminished. You can see HI less than HO from the ray diagram also. So